This is video number 5 in the exponent series, and we will be investigating negative exponents. To investigate exponents, we can look at patterns. And so on the left-hand column of this table, we have exponents written in exponential form. We'll start with a base of 2 to the 5th power, going down to the 4th power to the 3rd power. In the middle column, we have that exponent expressed in expanded form, or written out what it looks like. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. And in the final column, we have the value of that expression in standard form. So 2 times 2 times 2 times 2 times 2 is 32, or 2 to the 5th is 32. So we continue to look at what happens with this pattern. 2 to the 4th would be 4 2's all multiplied, 2 times 2 times 2 times 2. If I multiply that out, I get 16. 2 to the 3rd would be 2 times 2 times 2, and that has a value of 8. The next exponent would be 2 to the 2nd, and what you'll notice is that in this column, the exponent keeps decreasing by 1. So in the middle column, we're going to have 1 less 2. We're only going to have 2 2's, and the value of that is 4. So the next exponent would be 2 to the 1st, and we know that any number to the 1st power is just that number. So we'd have 1 2, and obviously the value of that would be 2. And here's where it gets a little tricky to think about. The next number in our pattern would be a base of 2, and if our pattern continues, the exponent would decrease by 1. So from 1, it would go to 0. That part of our pattern is easy to see, but sometimes this middle section is harder to understand. So what we can do is we can look at the final column on the far right. If we look at the first number 32 and it changed to 16, what really happened was we cut it in half, or we divided it by 2. From 16 to 8, again, we divide by 2. From 8 to 4, we divide by 2. From 4 to 2, we divide by 2. So it appears that that pattern is going to continue. So if I continue that pattern, and I had 2, and I divide that by 2, I'm going to get a value of 1. So we understand that 2 to the 0 power is 1. And that's something to make note of for later. So continuing our pattern on the left side, 2 to the 0, the next number would be 2 to the negative 1 if my exponent decreases by 1 each time and my base stays the same. And so the tricky part, again, is finding this middle value of how many 2's. But what we can do is look at the right-hand side and say, if I continue to divide by 2, what is 1 divided by 2? We know that is 1/2. So if I continue the pattern again, 2 to the negative 2nd, if I go over here to 1/2, then if I divide that by 2 again, I'm going to get 1/4. 2 to the negative 3rd, if I take 1/4, divide that by 2, or 1/2 of a 4th is an 1/8. 2 to the negative 4th, if I continue the pattern, would be 1/16, and so on. We'll go ahead and write that down. 2 to the negative 5th then would be 1/32. So next we notice that in the middle column we have some numbers that are in fractional form that can be written as exponents. For example, 1/2 can be written as 1/2 to the 1st, because 2 is 2 to the 1st power. 1/4 is 1/2 to the 2nd power, because 4 is 2 to the 2nd power. And so likewise, 1/8 could be 1/2 to the 3rd power, because 2 times 2 times 2 equals 8. And 1/2 to the 4th, and 1/2 to the 5th for these two. So now if you think this through, you might notice something. Notice that 2 to the negative 1st power is the same almost as 2 to the 1st power. The only difference is that it's the inverse. 2 to the 1st power is 2, or 2/1, and 2 to the negative 1st power is the inverse, 1/2. So if we look at 2 to the 3rd power and 2 to the negative 3rd power, 2 to the 3rd power is 8, and 2 to the negative third power is 1 over 8, or 1 over 2 to the positive third power. And that pattern is going to continue 2 to the fifth power and to the negative fifth power, for example. 2 to the fifth power is 32, and to the negative fifth power is 1 over 32, or the inverse of that. And we'd like to investigate if that happens for any other numbers, or if it's just unique to 2. So we can use 4 as a base and make a similar table. So 4 to the fifth is all these 4's multiplied together. It has a value of 1024. 4 to the fourth would be 4 4's multiplied together, which is 256. 4 to the third would be 4 times 4 times 4, which is 64. 4 to the second would be 2 factors of 4 multiplied, or 16. 4 to the first, of course, would be 1 4, or 4. And then we get to look for some patterns. So for this pattern, if you look at the left column, you'll notice just like last time, the base stays the same. In this case, our base is 4. But the exponent goes down by 1 each time. 5, 4, 3, 2, 1. And it'll keep going. On the far right-hand side, this time, we're not going to divide by 2. We're going to divide by 4. So 256 divided by 4 is 64. And it's just going to keep happening. Divide that by 4, you get 16. Divide that by 4, you get 4. And so if we continued our pattern, over here we would have 4 to the 0. That's going down by 1. And on the right-hand side, 4 divided by 4 is 1. So we'd have a value of 1. And I continue the pattern, 4 to the negative first. I'm going to take this 1 over here and divide that by 4. I'm going to end up with 1/4. So 4 to the negative second is 1/4 divided by 4, or 1/16. 4 to the negative third would be a fourth of that, or 1/64. 4 to the negative fourth would be 1 over 256. And 4 to the negative fifth is 1 over 1024. So again, in this different base, we see a pattern. 4 to the negative first has a value of 1/4, which is the inverse of 4 to the positive first. 4 is the inverse of 1/4. You see how those relate there. Now 4 to the negative second then would be 1 over 16, which is the inverse of 16, 4 to the second power. So another way I could write 1 over 16 is 1 over 4 to the positive second power. And 4 to the negative third can be written as 1 over 4 to the positive third, because that's really worth 1 over 64. And it has a relationship between 4 to the third. It's the inverse of it. So predict what would happen for 4 to the negative fourth. It would be 1 over 4 to the positive fourth, which is the same as 1 over 256. So that helps us work with negative exponents. So, for example, anytime you have a negative exponent, like let's say 7 to the negative second power, you know you can always write that as the reciprocal, 1 over 7 to the positive power. 8 to the negative fifth can be written 1 over 8 to the positive fifth. 10 to the negative third can be written as 1 over 10 to the positive third. And then from there, we can sometimes find the values of those if we need to. If it needs to be written in exponential form, we can leave it the way it is, but if we want to know the value of that, we can say on this first one, 1 over 7 to the second is the same as 1 over 49. And on this bottom one, 1 over 10 to the third is 1 over 1,000, because 10 to the third is 1,000. So that leads us to the general rule for changing a negative exponent into a positive exponent, and then possibly evaluating that. So if we had a base of a to a negative exponent power, like we'll just call it n, doesn't really matter what number it is, we can always rewrite that as 1 over the same base to the positive exponent n. That concludes this video. If you have any other questions, you can email me at this email address or check out my website at Weebly.